Okay, welcome back. So we've been talking about inverses and we've confirmed, we've looked at whether or not there is an inverse, but now we want to look at actually finding the inverses. Okay, so if you think about it, some of it can be done in your head. I would caution you a little bit about that with some of the harder ones, but I'm not saying you can't. Okay, but so if you had something that's added, what undoes adding? Well, that's subtraction. So we should expect to see subtraction of some point if we have addition. Same thing as if you see an x squared, we should expect to see a square root. Okay, so there are some of those things that we can get probably by just looking. Okay, but some of the harder ones, especially like the rational functions, it might be a little more difficult to do in your head. So what we have is a four-step process. Okay, and actually two of the steps are pretty they're just replacing things, so I would say it's really even just a two-step process. But so it's the four-step process to find it. Okay, and step one is a replacing step. We just replace f of x with y. Okay, and if you'll remember from our previous discussions, that is all f of x means. Okay, it just means y. We use it with functions, but now we need that y so that we can solve for it in just a second. Okay. Step two, if you think back to our first part, how did we find the inverse when we had a table? Okay. Well, all we did was switch the x and the y's around. Well, that's exactly what you have to do in your equation here. So what we do is we switch our x and y. Okay. And sometimes we do have two x's. That means you'll now have two y's. Okay, so notice that can happen. Okay. Third step, which is the longest step most of the time, okay, and that's when you get y by itself. Okay, so we're getting our new y by itself. So we have it in terms of x. So we'll have y equals blah, blah, blah. Okay? And then the last step is just a replacing step as well. So we replace y with the inverse of x. Okay? So that is our four-step process. Okay, we're going to start out easy and ease into the harder ones. Okay. So let me find our first one I want us to look at. Okay, so let's look at a line. So if we have a line, what do we expect for our inverse to be? Okay. Well, it should be a line as well, so that's a quick check. Okay. What two operations do we have going on here? We have a multiplication by 3. So somewhere in our answer, we should expect to see a division by 3. And we have an addition. Okay, so we should expect to see a subtraction. Does it have to necessarily be 1? And the answer is no. It all depends on the multiplication and the other pieces to it. But we should see a division and we should see a subtraction. Okay, so let's follow the four-step process. Step one is to just replace f of x with y. Can you just cross that out up above? Yes. Okay, but for this time, we're just going to put y there. Okay. Step two is replace the y with an x and the x with a y. So now we have x equals 3y plus 1. Okay. And now we have to get y by itself. So what's hanging on to y? Well, we have that plus 1 and we have the multiplying by 3. So we've got to move that 1 over first. So we get x minus 1 equals 3y. And finally, to get y by itself, we have x minus 1 over 3. Okay. Now, that might not look like a line to us, but if you will separate it out, okay, we can separate out tops. We get 1/3 x, okay, so that's 1x over 3, minus 1/3. Okay. So now does that look like a line in slope-intercept form? Here's my slope and here's my y-intercept. Okay. And step 4 just says replace the y with our inverse. Okay. So there is the inverse of 3x plus 1. We can check it by composition. We can check it with Desmos looking at the graphs. Okay, but hopefully that works for you. Okay. What about x cubed plus 1? Okay, so we have a cube and we have a addition of 1. So hopefully you are thinking that we should see a subtraction somewhere and a cubed root. Okay, these are not hard to do in your head as well, but just be careful in what order you do it. That could be the issue. Okay. Step 1, replace f of x with y. Okay. Step 2, do you remember? Switch x and y. So I have x equals y cubed plus 1. And then we just need to get y by itself. So the first thing to do would be to subtract 1. Okay. Now we have y cubed. So to get rid of a cube, we would take the cubed root of both sides. Now when we do cubed roots, do you need a plus or minus? And the answer is no, because with cubed roots, you either have a plus or a minus, and your problem will determine that. Okay. So there is your inverse of x cubed plus 1. Now I forgot, what did I do? I forgot step 4. Okay. Step 4 is we replace it. So I apologize about that. Okay. Now does that really matter? Not too much, okay, but we did want the 4 step. So there we go. Okay. So now let's look at f of x equals x squared. Now, does that bother anybody? We haven't been checking the other ones, but lines are 1 to 1. A cubic function is 1 to 1. But what about a parabola? What do we say? Right, this isn't 1 to 1. So what we actually have to do to be able to find its inverse is we have to restrict it. And in this case, they've asked us to restrict it to just x is greater than 0. So we're talking about that right part of the parabola. Okay. So if you have a non-1-to-1 function, you have to restrict it so you get a 1-to-1 function. So, and let's think about this a minute. Our domain on this function is 0 to infinity. What's our range? Well, it's all at the x-axis or above, so it's 0 to infinity. Okay. And we'll talk about why that's important in a minute. Okay. So we replace, in step 1, the f of x with y. So we get y equals x squared. Step 2, switch. So x equals y squared. Okay. Step 3, get y by itself. So we do need to take the square root. Okay. But, yes, we need a plus or minus when we take square roots. However, we only want the branch that matches with x being positive. Okay. And so that is going to be our positive branch. Okay. Because, and how do I know that? Well, let's go over here, and remember our domain is what our range was. And so our domain says we want 0 to infinity, which are our positive numbers. Okay, so if we wanted the negative ones, we would have had to put a minus here. But we go back up here and look at our range, and that says do positive. Okay, so last step is just replace, and we have our answer there. Feeling okay? Let's look at another quadratic. So here we have x squared minus 2. Using our transformations, this is a parabola, but it's been moved down 2. Okay. So if we look at our domain, we do need a restricted domain, right? So they do tell us that we want to be x is less than, or equal to 0. Okay. And so if x is less than or 0, we're talking about this right here. Okay. So this is negative infinity to 0 for our domain. Our range in this picture is from negative 2 to infinity. So we will be wanting to pay attention to this range in just a few minutes. Okay. So replace f of x with y. So we have x squared minus 2. What's the second step? Okay, we switch. So x equals y squared minus 2. And then again, we want to get y by itself. So we get y squared equals x plus 2. And then we take the square root, and we get x plus 2. And here, what do we want? Okay, well, we need our domain to be -2 to infinity. Okay, so we want to say that x is greater than -2. And let's see. I believe that we are leave it at that for now. I'll come back and check that in just a minute. And I'll leave you a note, but I forgot to check earlier. Okay, so let's call it good. Do you think a function can be its own inverse? Okay, well, there are actually functions that are their own inverses, so let's look at one. What that would mean is that they are symmetric around that line, y equals x. Okay, so even that line itself, right, y equals x would be its own inverse. Let's look at f of x equals -2 over x. So this is a rational function. Usually our rational functions are in that top right and bottom left, but that negative changes it. Okay? And so if we look here and think about it, high possibility that this is its own inverse. Okay, but let's check. So step 1, replace with y. Okay. Step 2, switch places. Step 3 is get y by itself. And if you remember our cross multiplying trick, if we can switch places on diagonals, so this is just y equals -2x. Or we can cross multiply and get there, but remember diagonals can switch places. So we do find out that -2 over x is its own inverse. Okay, and we could confirm that by graphing. Okay. So now let's look at one more. Actually, maybe 2 more. We'll see what this one looks like. Okay, so let's look at a rational function. So f of x equals x minus 3 over x plus 2. So this is the one where we have 2 x's, and so that means we have 2 y's, and so that throws off people, but let's see what we can do. Okay, so try to stay frame. So y equals x minus 3 over x plus 2. And I think I'm going to go across, so I use my paper more wisely. Okay. Now we switch places, so x equals y minus 3 over y plus 2. Now, what do we do when there are 2 y's? Well, we've got to get them where we can work with them together. Okay, so here I now want to cross multiply. If you have something on the bottom, it's always good to get it up to the top. Okay, so I get x times y plus 2 equals y minus 3. Okay. And now we want to go ahead and distribute because we need that y where we can work with it. Okay. Make sure we're following along here. So we get xy plus 2x equals y minus 3. And so this is where people get stuck. And just know that we have 2 y's here and we need them on the same side. Okay. So let's kick everybody off to another side. So I'm going to bring my y over here and my x over there. You can do it the other way, but whatever works. Okay. So xy stays, but I'm going to kick the 2x off, so it becomes a -2x over on this other side. Okay. And then the y needs to move to the other side, so we kick it off with the other sign. So xy minus y. And this -3 wants to stay, so we're good. Okay. Now, we need to make this where we can work with our y's together. So all you have to do is pull the y out. Okay. So now we have y, pull it out. And what are we left with in that first term? Well, we are left with an x. And if we pull out a y here, that just means divide, you're left with -1. Okay, so we have y times x minus 1 equals -2x minus 3. And your last step to get y by itself is to divide, right? This is something times y, so all you do is divide by it. So we get negative 2x minus 3 over x minus 1. And if we replace, this is what our more formal answer looks like. Okay. So if we have a rational equation, you should get a rational equation for its inverse. Okay. So a couple places that it's easy to forget, we have to cross multiply when we have something on the bottom here. We distribute, and then to get the y's by themselves, you have to pull out a y. Okay, so I'd like to do one more of those with you, and we'll call it good. Okay. So let's see what that looks like. Let's take 6x, or negative 6x minus 4 over 2x minus 8. Okay. And I already have the y in there. We're just going to call it good for now. Okay, so I rewrote it wrong and I put y instead of f of x, but that takes step 1. So now let's go to step 2, which is just switch. So I have negative 6y minus 4 over 2y minus 8 is equal to x. Okay. And so what do we do so that we can get that y where we can work with it? Right, we need to cross multiply. So now we have a negative 6y minus 4 is equal to x times 2y minus 8. Let's go ahead and distribute so that we can get that y where we need it. So negative 6y minus 4 equals 2xy minus 8x. Okay. So now everybody's out where we can move them around. Let's get y's on one side, x's on the other, and numbers on the other. I think I want my y's on this side. Okay. So that negative 6y needs to go the other side. Okay, so right now we have 2xy plus 6y. Okay. This negative 4 wants to stay. That 2xy wants to stay, and we need to kick off the 8x, so we're going to add 8x here. Okay. So let me take a minute and check that that's right. Okay. Now, how do we get that y out by itself? Okay. We just factor it. Okay. It doesn't have to be the common or the greatest common factor. It's just the one we want to deal with. Okay. So we have a y there. And in that first term, that leaves a 2x. In the second term, it leaves a 6. Okay. And so now we have y times something. All we have to do is divide by what's hanging on to y. So we end up with negative 4 plus 8x over 2x plus 6 is equal to y. Okay. Or we could put our inverse. And there you have it. Okay. So what I would also like you to try is page 240, 39 through 53 odd. Okay. And again, I'll have those answers, or you can check them in your back of your book. Okay. Let me know if you have questions, and just keep trying and working on it. And we will see you later.